Hi there, I'm Mr. Orr, and we're looking today at section 5.6, which is graphing inequalities in two variables. So if you have two variables, that means we're going to be on a coordinate grid. Let me just review for a moment the process of graphing with equalities. So I drew one up here, y equals 3x minus 4. Now you'll recall that the minus 4 means that we are going to locate the y-intercept at negative 4. The 3 is the slope, so we're going to go up 3 over 1, up 3 over 1. We only need to do that once, really. And then if I can find back here a meter stick, I will draw a straight line, or attempt to draw a straight line that connects those, and that would be the graphing the linear equation y equals 3x minus 4. Now, what I'm going to do is turn this into an inequality. Let's say y is less than 3x minus 4. Now, the first thing we do is to pretend that it is an equation, 3x minus 4, and we find the line, as we did here. The next thing that we do is to look to see whether that line is going to be solid or dotted. And you will recall from graphing inequalities like this, x is greater than 2. Okay, let's say we had 0, 1, and 2. And 2 is here. X is greater than 2 would be an open circle and a line going this way. Well, on the graph, the open circle versus the closed circle is going to be a dotted line, which would be the equivalent of the open circle, and a solid line, which would be the equivalent of a closed circle. The dotted line means that this line itself is not included in the inequality, as in this point not being included here, and the solid line is equivalent to a closed circle, which means that that line itself, or this point, is included in the graph. All right, so in this case, we do not have, and here, let me go back to this for a second. X is greater than 2 would look like that. X is greater than or equal to 2 would look like that. All right, so here we have the equivalent of a dotted line. There is no equal underneath here. If there was, it would be solid, but without it, it's a dotted line, so I have to go back here and make my line dotted. Makes a mess, but we'll do it that way anyway. All right, now we have a dotted line representing y equals 3x minus 4. But what we have to do is determine the shading. Now, when we had an inequality, and we had at 0, x is greater than 2, we had the open circle, and then we had an arrow with a line pointing in that direction or in the other direction, depending on whether this was a greater than or less than. Over here, we have an entire region instead of just a set of points here, which allowed us to put a line with an arrow. Over here, we have a region. So it's either going to be this region on this side or this region on this side, just like if you had the point there, the region was either this direction or it was the opposite direction. Well, the equivalent of that over here is this or this, but we have to figure out which one. So in order to do that, we go back up here and look for a point, any point that we can test. Because if we test a point on this side and it works, then this will be the side we shade. If we test a point on this side and it works, then this will be the side that we shade. The opposite is also true. If we test a point over here and it fails, then we're going to shade the opposite side. So pay attention to whether the point passes or fails, and I'll show you what I mean by that in a moment. But let's figure out what point to test. Well, I could test any point. I could test 3,562 and negative 1,874, but why be so difficult when we could pick 0, 0? Unless 0, 0 falls right on the line, you will either find out that it works, in which case you shade the side it's on, or it fails, in which case you shade the other side. So let's look. If I put 0, 0 in, I get 0 is less than, now 3 times 0 is 0, minus 4. I don't need this anymore. is 0 less than negative 4? No, on a number line, it is greater than negative 4. So, that failed. This point did not work, and therefore we are going to shade the side that 0, 0 is not on. Okay? Now, I'm going to do several more of these because they take just a little bit of getting used to. So, let's do the next one here. We will find is, let me pick one here. Y is, well, let's do one where we have to solve for y. So I'm going to do 8x plus y is less than or equal to 6. 8x plus y less than or equal to 6. I subtract the 8x from both sides, and I get y is less than or equal to negative 8x plus 6. All right, now, plus 6 is here, the y-intercept. Slope is down 8 over 1. So that would be right here, down 1, 2, 3, 4, 5, 6, 7, 8, and over 1. And I'm now going to shade, but I'd like to know before I draw this line, is it going to be dotted or solid? Well, there's the equal sign that tells me it's going to be solid. So I can make a solid line without having to worry about changing it later to a dotted line as long as I pay attention to that right from the start. So here's the line. And with this marker, it turns out nice and dark. I missed a little bit down there. Okay, so there's my line, solid line. Now I want to find out which side to shade. Well, 0, 0 is right here, and it's not on the line, so I can use it. So 0 is less than or equal to, this goes to 0, 6. Is 0 less than or equal to 6? Yes, indeed. So this side works because 0, 0 worked. What you'll find is that if one point works on one side or the other, all points on that side will work. You only have to test one. All right, there is a second one. Let's try a third one where you have to be a little bit more careful. Let's try this one, negative 4x minus 4. No, don't like that one. Just a minute. Let me find one that I do like better. Don't like, why are those not to my liking? Let's do none of those. Equalities into variables. All right, we'll make one up. 3x minus 4y is greater than, just greater than 12. Okay, very basic one. Okay, I'm going to subtract the 3x. So I get negative 4y is greater than negative 3x plus 12. I have to divide by negative 4 now. Negative 4 and negative 4. Those cancel. I get y. This sign, remember to switch it because we're dividing by a negative. So it becomes y is less than 3/4 x minus 3. All right, let's go back to here. And we'll do minus 3 right here. And then up 3 over 4. So 1, 2, 3 over 1, 2, 3, 4. That looks like that. Solid or dotted? That's going to be a dotted line. There's no equal sign here, so this is the equivalent of the open circle on the number line. So this is a dotted line. If I know that at the start, I just make it dotted right from the beginning. So I now have this here. All right, there's my dotted line. Last thing I have to do is test. 0, 0 is not on the line, so I can test 0, 0. 0 is less than, this goes to 0, negative 3. Is 0 less than negative 3? No. So 0, 0 failed, so I'm going to do the other side. All right? Now the only difference, if it goes through 0, 0, then you just have to pick a different point. Okay? Let's say you had y is greater than, or that's all right, y is greater than 1/2 x. Okay, so your y-intercept is 0. Now, I can put this in here because remember this is plus 0. So that's the y-intercept. I go up 1 over 2, which takes me to here. That's a dotted line because there's no equal sign underneath the inequality. So I make a dotted line here. Okay, now the only difference here is I can't use 0, 0 because it's right on the line. It won't tell me which side I want. So I can use something else. I can use 1, 1, which is not on the line. Let's try that. That's an easy one to use. So 1 is greater than 1 times a half, which is a half. Is 1 greater than a half? Yes, indeed. So this worked. So I'm going to shade the side that 1, 1 was on. Okay? It's that simple. Now, I believe that covers this lesson, and in fact, that covers the end of this chapter. So we will be having a quiz, and I will be asking you to review some of these lessons on video, and we will reconvene in class sometime soon. Thank you very much.